will buy AFDD. You will buy AFDD, or I will come round your home and kill you. Is that a good enough marketing campaign? Well, actually, technically, I won't kill you because your argument. But anyway, sorry.
Hello and welcome to another E5 Group podcast. I'm your host Dan Jackson, aka Dan's the Engineer, and today we're talking AFDDs, and I'm here with Ryan Dempsey. Hello, Ryan.
Hi, mate. Yep, I'm here.
Paul Meenan. Hello, Paul.
Hello.
Mr. John Ward. How are you?
Hello, I'm all right.
And Sparky Ninja, Dave Watts. How are you, Dave?
I'm fine, buddy. How are you?
I'm very good, thank you. I'm very good. Now, AFDDs, I've got to be honest, guys, I am really behind with the times compared to you lot, honestly, because I was out of the country, didn't really pay much attention to the technical side. And obviously you've been doing quite a lot of it, like you and Paul went to the
Vienna. We did. We flew across to Vienna to the Eaton factory and had the most mind-blowing time, to say the least. We I think this goes back about 2 years ago now to when the DPC first came out, and there was a arc fault detection. If I remember rightly, the regulation, because I was looking at the DPC yesterday, it says arc fault detection may be used. It was a very wishy-worded. Now it's obviously recommended. But in the original regulation, it said may be used. And I thought, well, what the hell are these devices? And as we know, we were going around and doing talks on this. So I had to really dive into the research of what these devices are. And it took me weeks and weeks and weeks before I started. My brain was melting. I think Dave's brain was melting as well. We were talking a lot as to how does this work? And it was, I think it became, I think we became aware very quickly that there was a fundamental rethink needed as to how we approach selecting and erecting this technology. And I think it really helped going to the manufacturer and basically saying to them, these are all the negatives that we have about these devices, and having them answer every single one. I mean, skipping forward to when we did go and meet them, they very lovingly recreated John Ward's bench, which was a very odd and strange thing, but they literally recreated his bench, and we had an Austrian scientist apologizing for small inaccurate details, recreating John Ward's testing, and then explaining to us that what he was doing was creating low energy sparks, not arcs. And we were like looking at each other going, oh, okay, so these AFDD devices have a level or a magnitude of energy required in them to create a stable arc, or sufficient energy must pass to create sufficient heat to cause the breakdown of the outer insulations, which then carbonizes. And this thing can happen in seconds. And you're like, wow, this is pretty mind-blowing technology. So how the hell do you explain that to a hairy-arsed electrician? Excuse my vernacular. So it's been a massive journey of trying to understand a really, really complex, almost scientific subject. Because if you turn around to someone and say, AFDD, what does it do? It analyzes the sine wave. Well, electricians don't really think of the sine wave on a daily basis, do we?
No.
Hence the huge problem.
Well, there's a lot of electricians who are really reluctant to use the kit, even though it's a recommendation, because it's adding cost on all the time. But in principle, when I first heard of AFDDs, I love the idea because it, in theory, it's a great thing. If it can stop, and protect fires from happening in arcs, it's a great thing.
Yeah, I think, I think we kicked off, didn't we, on social media the other day? We had, so for those listening, myself, Paul Skirm, went to Eaton to their R&D labs, and we saw a lot of stuff and got to do a lot of blowing up of stuff and melting of things, which sadly they wouldn't let us film in there. But it was a research lab that I wanted to steal half the things in it. I'm sure John and Dave would have nicked everything that they legally could get their hands on. And then obviously myself, Dave and Paul then also have been to the Electrium offices, where they very kindly took us on a briefing of their application of technology. And I think it's fair to say that both devices, while complying with BSEN 62606, they slightly operate differently. Excuse me 1 second, I want to put my phone on silent.
Yeah, I mean, it's worth mentioning. Obviously, we heard about the AFDD device way ahead, obviously, with the public draft, but we weren't given any real education. So those of us who actually put it upon ourselves to do CPD and to look for that, we went to the first place we could, and that was obviously where the AFCI exists in the US. So we found the whole history of the technology and the footprint and the background and the tales and the development and the progress and the implementation and the code. And there was always a bad smell around those devices. And a lot of the content that we created had to go with some assumption that we went with what information that we had. But it was that information that really made the manufacturers like Eaton approach us and offer this transparency for both Pauls and myself. I couldn't go to get this information, and obviously further on with Electrium. So transparency from these manufacturers has really been what's needed. And I go around in circles really because, again, the manufacturers, they haven't done enough to kind of help explain this technology to electricians to the point where Paul has just mentioned, where we're talking about a sustained arc that results in a level of heat intensity where the level of energy created by that existing arc that is constantly there creates the thermal effect, which is why this exists in chapter 42. So it's a steep learning curve, which Paul loves to cover, the fact that electricians need to be educated in this area.
For me, it blew me away because I'll be honest with you, I went to Eton almost fixed bayonets, to use an old military term. I was like, right, I'm not a fan of this technology. I'm not accepting it. I don't believe it. The American issues are too robust for us not to challenge this. And within half an hour, I'm looking at Paul Skirman, I'm going, oh, okay, these guys, the stuff they're working on in Europe is like this distant cousin of the American stuff. It's the next iteration. You know, the characteristics of everything inside is different because the power, the energy, the loading, the voltage is completely different in America. They run a different energy system in America. While the principles are the same, they've literally developed the next level. I mean, Eaton's AFDD device, it was patented in 2009. And when they went through it incredibly detailed, it is different to the way Electrium do theirs. I mean, one of the huge differences between the two that I noticed is the Eaton AFDD, when you reset the breaker and it gives you the yellow flashes and tells you what went on, well, the Eaton one has like 6 different levels of fault code. The Electrium one doesn't. I think it has 3 or 4. And the reason being is the Eaton one will tell you whether the arc fault was within a connected load. Now, the Electrium one doesn't do that. So there is some subtle differences into the application of technology. But the one thing we learned was these guys have looked at that standard, used it as a minimum benchmark, because we're so sad. We've researched even articles that have said that the testing criteria in the original UL American standard needed to be looked at. And the Eaton guys agreed, and they said, yeah, well, but it's the minimum. We went all the way to Austria with these people we've never met before and said 62606 is an absolute minimum. We're working from it, not to it. Which you're like, oh, okay, this can only be a good thing. They are really going for the next generation of stuff. How the hell do I explain this to electricians? How do you even start to?
But also this extra effort they've put in over in Vienna, I think, has resulted in this issue of actually putting the AFDD into the single module. Because one of the other things we got from that visit was the question of whether or not a single module could be created without any compromise to 62606 or 61009. Which they were fairly confident that there'd have to be some level of compromise. We spoke to a couple of manufacturers, we won't name who, but they were fairly honest, and they said there would be some, but Electrium did stand ground to say there would be no compromise in this new single module.
And that just shows you the difference in how people apply technology. Some people have got the knack and the ability to get the technology miniaturized. Others don't have that capability, which is why I think it's very cutthroat at the moment in circuit breaker protection, because you're right, one guy did say to us, if you miniaturize, you have to compromise on some sort of performance criteria. And I think on one of the AFDDs we've seen it doesn't do double pole, or it only looks for arc on the line conductor, if I remember one of the more cheaper brands. So there is a difference, and I think over time we've learned 62606 again is a very minimalistic standard. But it's the education of electricians. I mean, I've got an Eaton video that I'm kind of there or thereabouts ready to film, but it's that narrative, it's the wording of how does the electrician understand how he selects and erects these devices, given the fact that if he goes with an Electrium one, he's got a very good compact product, which he'll be very familiar with because they're miniaturized breakers, you'll fit in any board. But then, like the Eaton ones are 3 gangs. Is he going to be selecting an Eaton one? Well, an Eaton one, it can be argued the Eaton one does more than the Wilex one. Because if it tells you that what the connected loads are, if they're at fault, then that's a good thing. And one of the things that we've had, I think, from more than one manufacturer is one of the biggest bits of feedback they've had rolling out AFDD is like when RCD came out, the connected loads have caused havoc. Whether it be from an electromagnetic compatibility, feedback. I mean, Ryan, we were talking about this the other day, weren't we? They were actually saying to us that there was certain noises created by the connected loads which were causing nuisance tripping. So I think we're now at that point where we were 20 plus years ago when voltage operated earth leakage became current RCDs, and people didn't want stuff tripping out. You know, quality of white goods will be under question, quality of products imported. I mean, God help John if John ever put arc fault detection devices in your house with all the weird and wonderful equipment that you plug in, John.
Yeah, I mean, my problem mainly with what's come out so far is that a lot of the stuff that was put out by manufacturers, and it was mainly their marketing departments, was a complete load of old rubbish.
Yep.
And it was sort of just giving people the impression that these were some kind of miracle devices that you just simply plug in and it fixes all these problems. And even some of the guys, that one from Beamer that they put out, I mean, some of the stuff in there was complete nonsense because they got that little diagram of a table lamp with a flex being caught in the door. And of course, in reality, the current from a single table lamp is pretty much nothing, and none of the devices would even detect. So they've put all this stuff out there, and it's really misleading right from the start. So it's a bit of a bad start for the whole thing.
I think I remember, I think it was Schneider, one of them had a video of a boy and his dog in the bedroom, and they plugged a clock radio into the socket, the extension lead next to the bed. It was just a digital clock radio, I believe, or a table lamp.
Okay, so it's not. Does this not raise a separate question from all we're talking about arc fault detection, and we're probably about to get into a little bit more of a technical kind of discussion around arc fault detection. But what we're talking about here is how those who we would look towards, like Beamer, unbelievably strong organization in the electrical industry, and Schneider and Eaton and Electrium and all of these different other firms, all of these people are marketing their devices as if people are stupid.
Yeah. I remember watching a webinar, and one of the guys said, you want this on your cables if you drill a cable in a wall. And this is back when we assumed it would be at 2.5 amp at least. They have just, the answer has been these devices stop fires, just like the old RCD argument. It's just now it's like it's erase that and now do it for AFDDs. These stop fires, these stop fires. Yeah. It goes full circle though with the problem with legislation, which I'm sure we'll start talking about very soon with regards to defence, etc. If we ignore the messages, but we have to have more of a sensible education from the manufacturers about how to apply these devices and how to correctly select them.
Can I just add, I am an idiot. I actually, every day I wake up, I actually tell myself I am an idiot, and I like to consider myself an idiot, but not in a bad way. Don't you dare go around thinking you know everything about everything, because you'll be seen as a narcissist or an arrogant. Although I know some people in our industry think I'm an arrogant twat anyway.
So listen, Meenan, you just nearly got Mrs. Dempsey involved in this podcast, because when you said that, she's making me a cup of tea and she giggled. So there's a very good chance that somebody might have just heard Mrs. Dempsey in this podcast.
Oh, sorry, Mrs. Dempsey. Nice mug. Right, just for everyone here, just who's listening, going arc fault. What is arc fault detection? Arc fault detection is known as arc fault circuit interrupter, arc fault interrupter, arc fault detection device. It's known in various names around the world. They're marketed as a fire prevention device, and they're seen as closing the gaps in terms of electrical protection. So this is, I call it additional. This is the last phase you could ever protect, I think. And what this device does is it protects from very, very minor parallel arc that could occur from insulation breakdown between two cores. Although personally, I would assume that if you had that, you would have a big problem anyway, and the breaker would trip. Series arc detection is really the end game. That, and also the overheating of electronic components in loads, white goods. That it would then, that's that. This is almost the unicorn device to prevent the next Grenfell, you could say, actually. The trouble is it's a device that monitors a sinusoidal sine wave. Try saying that in a whole
Just take a step back. The one thing that I'd like to see, or not, is reference to Grenfell in terms of safety devices. There's a report that's just come out about Grenfell, and all they're doing is focusing on fire doors, and it is appalling. The content of having all of these chartered fellows of different institutes around the world trying to see what's right and what's wrong in terms of these different devices that could have saved 79 people's lives. Categorically, arc fault detection would not have saved one of those people in that building. That building had multiple errors, and all of those people died catastrophically because of all of those errors together. Arc fault detection would not have saved anyone in that building. Which is, it sounds harsh. However, don't say it in this podcast, because the manufacturers will dine out on it. And the manufacturers will start putting it out.
I'm not doing this podcast for manufacturers to dine out on.
No.
The fact is if it was an electrical problem that caused it from an overheated conductor, then the theory is if there was a loose terminal on the back of that fridge, and it was an old style fridge that was pulling more than 2.5 amps, it could have prevented that bursting into flames, which would have let's put it like this. Grenfell, if it was white goods that caused it, all it did was expose a catalogue of catastrophic errors in the management of the building. Yeah. Everybody is too hung up about the management of the building, the stay put policy, the cladding, and everything else that they can pin that's huge quantifiable things they can touch, sense, feel, and manage. Electrics can't see it, don't understand it, irrelevant.
Yeah.
Simple is these devices on a series arc, if it was in the back of a white goods, would have picked it up and could have prevented fire outbreak, but obviously that wouldn't have had the desired effect.
No, I've heard a lot of horror stories, and one of the horror stories, just to kind of, I speak to quite a lot in social housing. One of the horror stories I've heard is that the white goods in question was constantly tripping the device, the RCD, and so they shifted it from the RCD side onto an MCB side to stop the unwanted tripping, as they refer to it now, not nuisance tripping. So if it was an arc fault detection device, exactly the same would have happened. It would have constantly kept tripping. Somebody would have just flipped it across. So yeah, it's sad. It is sad, and there's so many what ifs, isn't there, with things like this? It's
yeah. I mean, there's a lot to actually also look at with regards to the white goods. There's a lot of, every week there's a new dishwasher, tumble dryer, washing machine being recalled, and they seem to always kind of get a pass or a free pass, just raise awareness and carry on moving on. I remember finding a video from like the early 90s, Tomorrow's World, I think it was. There was a company called Firetrace. They're still around today. They put this system in control panels. Dan's nodding his head. He's familiar with them. And the guy who invented the technology was on Tomorrow's World, and he put it into a rear projection television. And he demonstrated that if a fire starts in the TV unit, then the fire suppression will extinguish the fire. But the problem is you can't put that technology into things like white goods that are made for obviously exporting and importing. But something as simple as that would have also stopped the fire. I looked at that way back when I did the investigation work for Shirley Towers, where the fire started by a tea light that was on the TV that fell in, and that's where firefighters died. There's always other causes. AFDDs, as Paul's been saying, could have. We don't know.
We're in that journey where they are where RCDs were when they first came out. One, there's a behavioural barrier, there's a competency barrier, there's the correct application and use barrier. There's also another barrier that's come out, whereas connected white goods, I mean, Dave just said it, all these devices, all this new technology that's coming out, we're only just introducing the big picture of RCDs to people, the different types. Okay, you've got Worcester Bosch boilers now by default want Type A RCD protections for all Worcester Bosch boilers. So that's now causing, that's, as you can imagine, be fun and games for all the plumbing installers, because they're having to go and get socket outlets or fuse spurs with Type A RCDs. But is it Greenhams or whatever they're called? They've just released a load, which goes back to that WhatsApp conversation we were having earlier on about they've omitted SRCDs out of the regs.
But the problem is, Paul, the plumbers won't know that, though. That's the thing.
In fairness, some of them do. The ones on social
engineers
media do. You know, the PB plumber and the likes. They are actually clued into it and
but
sharing
generally,
data sheets online. But generally, yeah, they ain't. No,
You're talking now with social media. You're talking probably about not even 5% of circulating plumbers and stuff. So
yeah,
it's a big community, but it's when you think about how many plumbers there are.
Mm-hmm.
I mean, a lot of electricians don't understand the difference between Type A and Type AC RCDs, let alone plumbers.
No, that's true. I'm one of them. No, I'm only joking. Yeah, so there's an opportunity, I think, then where there are people who won't want to know, and there are probably everybody that needs to know. The trouble is, everybody, as Dave rightly says, has different ways of learning, different mechanisms, different functions. We all learn from our mistakes. Nobody wants to make a mistake because it costs a fortune. So what is the mechanism for everybody? And this is one of the things I've held out and recorded my Eaton video as to how many times do I have to explain how an arc fault detection device works to be able to reach different minds. Dempsey's looking a little bit miffed at me at the moment on the Skype. But just on these devices, for people who may be wondering if there's any tripping times or anything like that, there is actually. So within the standard 62606, the tripping time for the units differs depending on the current rating. So under the 62606 standard, it requires a minimum of 2.5 amps to be able to trip within under 1 second. It goes up to 40 amps under the current standard, although I know that's extended to 63, I believe, in the new one. And if you have a 40 amp arc fault, it has to disconnect within 0.12 seconds, which is huge. That's super quick. That is, it's a lot quicker than RCDs. So there is a huge criteria for this to analyze the sine wave very, very quickly based on large volumes of energy passing through and to disconnect. And in fairness, when we were with Eaton, we threw everything we had at it, including the kitchen sink, and it survived. And John, you've got your own mega rig, haven't you, John?
Yeah, I've made a rig actually to test these things. I've done a video on it a while ago, but haven't actually done any real testing on it just yet. We will be doing that at some point in the future. I think the point about the current that you made is an important one, because bearing in mind that these devices are not suitable for every circuit or every type of circuit, simply because the minimum current required to actually make these things work is reasonably high. I mean, the 2.5 amps there. So if they put that on a lighting circuit, there's not going to be a whole lot of point, because even if you get a fault on a lighting circuit, the total load on it is in many cases going to be far less than 2.5 amps anyway, certainly with things like LED lighting. And this goes back to the marketing thing I said earlier, in that you had certain manufacturers putting out pictures or sort of mock-ups of consumer units with every single circuit and a huge rack of AFDDs in there. But of course, in reality, that's probably not what people want to be thinking about, because there's quite a lot of circuits where the total load is never going to be enough to actually operate these things in the first place. So again, it seems to be this sort of marketing issue that someone's put out and said, yeah, this is great, put them on everything. But of course, from the technical point of view, probably not what you want to be doing.
Yeah, there needs to be much more education across the board, doesn't there? And obviously, it is very manufacturer-led, as you're saying, Paul. A lot of the different manufacturers and their kit works slightly differently. And there needs to be education, but there can't be a conflict of interest there to try and sell a product for the sake of selling it.
Well, I'm not. Listen, we don't get any money for doing anything anyway, so there's no. For me, I'm a huge fan of, as we all know, helping individuals upskill themselves and their knowledge, and if it helps them earn more money for their family, great. But in the right way, obviously. This technology is brand new, and it's fairly evident there are small differences in how they've worked from the standard 62606, and I think people are going to be very what's the word, trepidatious with how they apply this technology. I think in new builds and stuff, I think yes, it's worthwhile. The Electrum one is the most obvious one that will fit and be more common and easier for Sparks to install. But the standard requires minimum of 2.5 amps. But excuse me, there is the Electrum claim of 1.5 amps is exceeding that standard. Now I don't know how they've done that, because that would effectively, what's the best term to use? They would have to very finely tune the microprocessors inside, and also the level of energy to cause danger. I mean, Dave, you've done a lot of arc flash stuff. Is there an absolute minimum level of energy for arc flash to be of a significant hazard? Because I thought 2.5 amps was a reasonable amount.
The amperage is varied because it's down to number of, total energy, but also duration of the arc. What we, in the arc flash world, what we say is anything that results in a second degree burn, which we would say 1.2 calories. If the energy level is 1.2 calories, then the conclusion is there's enough energy for a second degree burn, and that would then result in excessive or introducing improvements in PPE. But that's with regards to arc flash, which is a release of energy for a workout in a panel. We're here talking about a series arc where a lot lower level of energy will build up a rising temperature under chapter 42. So I think the rigs that we see, is it like 500 joules or 400 joules is the trigger, where they then say fire? You played with the rig the other day. What joules level was fire?
Oh,
yeah, it went to 500.
Yeah.
It clicked up to 500, didn't it? And then at 500 it said fire. So
yeah, so no level of current would exactly reach that. It's down to duration as well. So a huge amount of current for a very short duration would be a lot lower energy than a much lower current for a very, very long time. So it's a combination of a level of current and time, and that's how they determine the level of energy. So as these devices have to operate in the time frame that you just mentioned, I should imagine they've just reverse calculated that to then say, well, this level of ampage for that duration would equal that energy, and at that ampage they disconnect. That's just me just randomly thinking about how they may do that.
it was, if I remember rightly, when they did the test, correct me if I'm wrong, Paul, when they did the test, they put it at 2 amps. There was the way to put it to 2 amps and 3.5 amps. And we just did it on 2 amps, and that tripped in less than 1 second at 28 joules, which at 1 second at 28 watts. So that was how quick it tripped, and that was the numbers that were on the device. So,
I mean, at the end of the day, it's in the manufacturer's interest for these devices to operate as low a current as they can, because then their application isn't questionable, really, is it?
I can definitely see Paul talking. I just can't hear him.
Yeah, you moved your mic, mate.
Yeah, sorry. So I got mute button. It's so you don't hear background clicking and stuff. I'm trying to learn this, trying to be considerate while you're talking. So again, yeah, you were right. You were right about the 28 watts. That is nothing. But again, that then just shows you how robust this technology is. I mean, I think I even explained to somebody. I said, imagine some bloke sat in an electrical device who just looks at this visible sine wave. But the best thing I ever saw that made it finally click for me was we looked at this. I think it was like an 8-channel oscilloscope, and they had the sine wave, and across the screen they had 50 perfect waveforms, and they were able to zoom into every single one of those 50, and they would create dozens of different noises and arcs and simulate shorts and series arcs, and they would show you what was the friendly and what was the non-friendly. And it was quite amazing because we were doing some things to it where it was creating noise of those 50 sine wave sections that it analysed, again, 50 in 1 second. You would see the voltage and energy levels change, and you'd think, oh, there you go, that's going to trip. But it knew not to, because it had lots and lots of it had software coding in it that said, if the voltage rises but the current drops, that isn't an arc, because the energy levels are dropping off. But they then had software that said if the energy levels increase along with a drop of voltage or an increase of voltage for more than, say, 10 of those 50 sine waves, then you will trip. And the secret sauce in it is identifying the components of an arc, which I think Siemens have done in their little hexagonal what 6 components constitute an arc, which is very difficult to explain to people, never mind to read. But yeah, you have to really see it in practice. That's why I think when John is testing in anger, hopefully he'll have the local fire brigade round. It should make some great further videos, John.
Ryan, you posted something on LinkedIn recently with you and Paul. Obviously, you got to play with some devices, and there was, I think you had some negative feedback.
No, I wouldn't say it was negative. I think what it did, it brought the questions that everybody has to the forefront. What I really like about E5 and what we do collectively is we give people the opportunity to vent, and we ask the questions that people don't necessarily want to stand up and see it out aloud. They talk about it to their friends and their close-knit community. And what we do is we go out, we do a bit of R&D, we try and kind of research things that are in the industry, and then we see the things that we learn, and people latch onto that. And you're right, there was a lot of people who said things. I wouldn't say they were negative comments. They were just uncertain about certain things, and or they were kind of saying what they've been taught or what they've been told, which conflicted what we'd said. So
what Ryan hasn't said there was he wasn't up for an hour writing a novel response to some of the questions online, where I literally ended up opening up a Microsoft Word document, typing a load of stuff out and cut and pasting it into 3 or 4 answers because I'd maxed out the limits on the responses. There were lots of people who were just going, I don't get it, I don't get it, I don't get it. And this is the thing, like if you look at the Siemens documents, or Electrium, sorry, the components that make up an arc, the duration is key, the high frequency power, the synchronization between voltage, current, and that frequency, the current value itself, and the stability of the arcs are all key. But we don't think, nor do you imagine standing at a wholesaler saying, "Oh yeah, I'll tell you what, the high frequency stability of the arcs that I've got in these new LED drives are a nightmare for my AFDD devices." You're going, "Oh my God, the scientists are back." You know, when I was an apprentice, you walked onto a site and you used to get catcalls going, "Oh, here come the scientists." We'd be back. If guys understood this technology, we would be rocking and rolling. But we're not there yet. We're no way there yet, to be honest with you. And that's, again, one of the challenges we have with this technology and trying to share an applied knowledge of it.
So let me just the reason why I posted that, Dan, was Electrium came to my offices where Paul was. Paul and I were at my offices across in Liverpool, and they came to answer some of the questions that everybody has. And as we sat there, there was the how do you test it? How often is it tested? Does it self-test? What do we need to do? Do we need to have a separate piece of testing equipment to plug into a system to try and make sure that it works? How much is it going to cost? Which was a massive thing. There was so many questions that we had. Could you use them on a ring main? Can't use it on one leg of a ring main. Can we use it on lighting circuits? And then good on Electrium, and the reason why I posted it is because they came and they explained and they answered the questions just openly and honestly. And I kind of came away from the meeting, I don't know how Paul felt, but I came away from the meeting thinking, all right, I think I understand now. I think I understand that if we always did what we always did, we'd still be making fires with sticks. Things have to progress. Things have to move forward. Yeah. And although we've read these articles in America where the guy who came up with the arc fault detection devices has thrown his dummy out of the pram, and he said, "No, these don't work, and I'm moving back to Germany, and I'm going to go into hiding because people are going to kill me for it." He wrote that way back when there was a double, triple module arc fault detection device that did A, B, and C. What we see now in a single module device, and even with the double module that the guys went over to Vienna to see, what we see now is a million miles from that in terms of technology and innovation, and that's why I kind of put on what I thought was a positive post.
So the guy originally invented it, and yes, he rightfully questioned it. But years ago, when they originally invented it, it was with big lumps of metal, with coils, with resistors, with diodes, and all sorts. They didn't have microprocessors and electronics. I mean, the Eaton one that we saw, which they can't give us because it is part of their intellectual property right, it was pretty incredible seeing how many microprocessors were built on board. I mean, these devices, and I'll use the Eaton one as a perfect example. If for any reason the AFDD microprocessor fails through just age or defective manufacturing, then the device diverts back to an RCD. But they have a separate microprocessor that knows that has failed, and every 24 hours will trip the power out until you get someone out to attend to it, which is pretty darn good.
Was the time, was it less than 24 hours when they said, what was the 16 hours?
Oh, yeah. So with the Electrium one, if they, it's the same principle, but they've set it at every 16 hours. So depending on the time of day, it will trip out not at the same time every day. It will randomly go at various points within the day to get you to get someone out to look at it. But the red and yellow lights will both be on for the electrician to turn up and go, right, that module is buggered. So they've worked out a way of clearly understanding this. Now, before we go on, can I just add that in the very first edition of the wiring regulations, which was called Rules and Regulations Prevention of Fire Risks, it actually mentions in Regulation 7 arcs, because arc lighting. So arcs are nothing new. And if I really go super sad on you, in Regulation 532.1, note 3 of the Yellow Book, Amendment 3 of the 17th edition, states the following methods which are additional to requirements may also be employed, and it's the first reference of arc fault devices. So when they came out in the 18th and everyone went, oh my God, actually no, they were a sneaky little note, which makes you then wonder in the 18th edition what sneaky little notes they've got in now for the future. But I think we've realised that, and between us, we're kind of picking up now on what's coming down the line. We've kind of sussed out that they do bury little clues in there. But with arc fault devices, again, me and Paul go abroad to say, no, we don't want it. And then it turns out in Germany, in their national standard DIN VDE 0100-420, Amendment 1, they're mandatory from the 18th of December 2017. Slovakia, their standard, 60364-442. That is highly recommends them. They are now mandated in Austria, the USA. It's becoming more and more prevalent. These are the will of government or regulators or whatever these things are put in.
So Paul, that makes that brings us on to quite a really important point, which I think we should probably work through some of the comments on the post from LinkedIn. Call some people out on some of their comments. I'm happy to start seeing people's names, but the comment you just made, in Germany they're mandated, you have to fit them.
Yes.
And wherever else you said they are highly recommended. However, the British wiring regulations are recommended. There are some organisations across our country who we hold dear to our heart, who have operated in this industry for over 100 years, who are the grandfathers of this industry, who stand up in front of hundreds of people and say they're only recommended. Now, there's a difference between mandated, highly recommended, only recommended, and recommended.
Yeah.
We need to be mindful how we market this.
Yeah, I mean, one of the very popular YouTubers added a little comment on AFDDs just in the middle of a normal video, and he basically said he'd just done his course at a college, and the lady who trained him said they're only recommended. That basically means no, don't worry about it now. That was the opinion that he had, that he gave that to all of his viewers. They're recommended, which means shelve it. But going back to what Paul was just mentioning, ARCs have been in there forever. I do health and safety training. I always refer to HSR 25, HSG 85, and it's always about the effects of electricity, which is not just electric shock. It's always been burns and fire and explosion and arcs. If a new technology has been developed to help with the danger of arcs, we need to embrace it, but we need to embrace it sensibly.
So I would say that the people who say it's recommended only are idiots. And I'll tell you why, because when I first started out, the people in my college said, RCDs, don't worry about them, boys. Don't worry about them. And this is genuine. I remember Paul Webb. When we were talking about RCDs, he would genuinely say, forgive my my impression, but he would turn around and go, if you fucking selected and erected it properly and it's enclosed in mechanical protection, you've selected your right overcurrent device, why the fuck do you need these extra devices? In actual fact, what he was saying was, we don't really understand how they work yet. We think there might be a benefit, but don't worry about it at the moment because you're on your journey of learning. You'll eventually get there. I think these are being worded as recommended only to alleviate the panic and fear within installers and contractors who feel they're going to be priced out of the market, when the regulation 42117 clearly states arc fault detection devices conforming to 62606 are recommended as a means of providing additional protection against fire. So you have your supplementary means of protection with RCDs. This is an additional means of protection against fire because it does stuff that the RCDs doesn't do. And that's the key. And if people started to go on that journey, we've said this before, selecting and erecting through the regulations, working from them, you would make an informed choice whether to include or not include.
But it's worth just adding to the end of that these devices, not by their design, do assist with the decline in poor workmanship. They do protect against the decline in poor workmanship, and that will result in a bad opinion from a lot of the old guard, as you say.
So they don't assist in the decline; they mitigate the decline in competency from the installer.
Same thing.
Well, kind of not, but yes, okay, yeah, we agree. Yeah, we agree to differ, but yeah, they do they are mitigation, pure and simple, for shitty electricians and piss poor attitudes and really bad behaviours across the industry. And if there are industry bodies saying they're recommended only, they are by default contributing to the de-skilling of their own members, which is fundamentally flawed.
Yep. So let us have a quick look at one of the replies to that post that went on to LinkedIn. I'm going to read out the paragraph, and then Paul, if I could ask you to just explain. In fact, if I could just ask you to explain Regulation 29 of the Electricity at Work Regs, 1989.
I've never heard of it. Electricity work regulation. Oh yeah, it's the defence one. It's my favourite one. It's the one that everybody ignores and is never really taught that often. Yeah, so Regulation 29 it's the defence clause, and effectively it's the one where if you were standing in front of a dock, you would have to demonstrate you took all reasonable steps to avoid a commissioning of an offence in breaching the former regulations, which was 4, 5, 6, 7, 8, I think it's 11, 12, 13, 14, 15, 16, if I remember rightly off the top of my head.
All the absolute regulations.
Yes, the shalls.
So I'm going to read out, we're not going to call them out on it, but I'm going to read out the paragraph. My defence will be, and I'm going to answer the question here. My defence will be that the people that wrote 7671 are supposed to be far more competent in these things than me. So much so that BSI have given them a license to write this standard, and it is also the guide the courts use to set installation standards to prosecute to. And if I don't think they shall be fitted, then who am I to argue? Okay, so just to address the first part of that, all of these people who sit on the committee are no more qualified than you, Mr. Author. The second part of that, BSI have not given them a license. The majority of those people are friends and they stroke each other's back, so they sit on these committees. It's nothing to do with being technically competent in a specific area. It's who you know and how long you've known them. The defence clause, the regulations should say shall. They should say they shall be fitted or they should be fitted. But we've took a step to decide to go recommended, to kind of softly educate the market. I totally disagree with this chap's comments in terms of it. It's his defence would be that the IET and GPL 64 and so on, they're more qualified than him. So who is he to argue with them? We need to get to a point where we are accountable, individual accountability. if I'm going to put and I own a company and I'm going to put lads and lasses into an environment, I'm not going to go to JPEL 64 and ask how should I kit these people out? What tools should I buy them? You are accountable for your actions. Therefore, you should be up to date and be able to make a judgment call on what is right and what is wrong for installations. So yeah, the person who wrote that, I like him a lot, but he needs to just kind of shake his head a little bit.
I think I know what you're talking about.
But that's the case for most electricians, though, Ryan. Most electricians will say exactly what you just said. The people who wrote BS 7671 know more than I, so therefore, who am I to argue? I heard it time and time again.
Well, let's close that loop right now. The people who write BS 7671 don't know more than you. They might be given information in an easier manner, but all they do is harmonize standards that are written in other countries, and therefore they have to sit and read a book and read a piece of paper and understand it to then apply it to the regulations that we work to. They don't know more than you. They may have applied themselves a little bit differently. They don't know more than you. So yeah, that should be bottomed out. I'd give anything to JPEL 64 to have a panel E, which is just here are Sparks who review all of the stuff that they do, because the regulations would be so much different or so different.
But if we tomorrow turned around and said every electrician is individually accountable and they can do what they want to their knowledge, the industry, the installations would be completely fucked, because the training is poor, the attitudes are poor, the whole industry, everything about it is just sloping down and down. And that's why, me personally, I know you guys as well, we're very passionate about what we do. This is why we do it. We do it for nothing.
So I'll tell you this. So anyone who wants to learn about our industry and become more knowledgeable than the people in the Wine Regs Committee, all you've got to do is look at the IEC 60364 standards. There are dozens of them, literally hundreds of them, and all they are is the people that sit on the JPEL committee are in and I'll use this because I've always thought this, they are in a privileged position. To sit on those committees should be an honour and a privilege to serve your industry, but more importantly, the people who you've worked with and where you have come from. And in my professional view, as a chartered fellow of the IET, I think some of the people that sit on those committees have lost sight or are completely blind to the fact that it is a privilege to sit on that committee to serve your industry and the safety of the electricians and the people who use electrical installations. These people sit in these committees and receive briefings on the latest requirements from the 60364 standards. They then choose under committee how they will interpret and include these into their into the BSM 671. That's what they do. They are paid as day jobs, let's be perfectly frank, because they all sit on voluntary regulatory bodies, so they're paid to go there. Some people are volunteers or some people are consultants, but they all go there for a reason. They are leaps and bounds ahead as far as the application of technology and understanding. We are not paid and we don't sit on those committees, but we are still it would be an honor, to be honest with you, but we are still leaps and bounds because we understand the mechanism now for changing our industry, and we see lots of poor marketing, bad behaviors, greed, nepotism, and it's one of the reasons why we do what we do, to try and educate those who want to upskill and stand in an ethical manner and behave themselves in an ethical way, rather than listen to the tripe that's thrown at them by industry bodies.
I think it's really important for people to think about longevity, because us five alone, the amount of time and money we've invested, along with a lot of other people, in the industry, the amount of time and money you've invested into the industry, you have got to think about the future, and what we do today matters for tomorrow. And that's why when people don't think about the bigger picture in 10 years time, in 15 years time, it does matter to you, because you don't just get out of this industry quickly if you want to. It's not a simple thing. Once you're in it, you're in it.
So I was at an event from a regulatory body, and I was there, and they were talking to hundreds of members about arc fault detection. And one of the individuals turned around and said, AFDDs detect downstream and upstream arcs, which is a complete and utter crock of shit. So I ended up putting my hand up and went, literally waving my hand at the open mic segment. And I had to say, sorry, look, they don't. And what became very prevalent was I knew more about the arc fault technology than those people who do it full time. And remember, lads, I work full time as a client. You know, that's my day job. My day job is not reading regulations and standards. It's my hobby. Learning all this is my hobby. And if these people who do it full time can't get it right, it kind of shows you the indicative state of how bad our industry is. And if anybody ever says the people on JPEL are smarter than electricians, some of them are. The specialists, the arc fault specialist manufacturers, but there's nothing stopping electricians being as smart as they want to be.
Yeah, I mean, is this podcast going out straight away, guys, by the way? Yeah?
Yes. Yeah,
right.
Let's whack
Good,
it straight.
Right. Well, I'm working today on a presentation for this Alexa exhibition this upcoming Thursday, Friday. And I've had my nose in 60364 all afternoon on my Sunday. I've looked at part 8.1, part 8.2, part 8.3, prosumer, energy efficiency. I've looked at chapter 57. I've got in front of me right now section 716, section 720, so we can look and talk about the next 10 years. So everything you've just been explaining is exactly what I've been looking into today. And it's not like I've had to find this today. We've had all this information in our previous endeavors and research. It's just a case of, oh, right, the information is there because we put the effort in.
Yes,
and
do the work.
It's easy to do. You just got to bother.
You've got to be bothered to do the work. And I have had, I'm not going to lie, I've had one person from a voluntary regulatory body stand in front of me and just in a miffed manner go, why do you do what you do? That was his words. And I just went, why not? You're not helping me very much. He didn't know what to say. He genuinely didn't know what to say.
Well, people don't understand it. I was with a chap last week, and I explained that I've just written a technical specification for a housing association in the Northwest and didn't charge them a penny for it. And he looked at me as if I'd kind of set fire to his house. He just, why have you done that? And I says, well, I've got the knowledge there. I've done it for a long time, and hundreds and thousands of people will benefit from that because it's social housing. And why wouldn't I? And people just don't get it. People don't get what we do. We're going down to Sandown on Thursday, Friday. We've all booked hotel rooms out of our own pocket. None of us are getting paid anything for it. No manufacturer is catering for us. They're not paying for our hotel rooms.
Nope.
We are literally going there to try and give all of this research and stuff that we've done to try and give people that information back, to give people a little bit more. So.
And I've explained this in a lot of my videos in why I set up, Dempsey engineered the whole thing. And it was to kind of help people around me kind of raise the game a little bit, because it helps raise the market in general and everybody benefits. And by helping each other, by providing education, by, all the research that's been done and, blogs that have been created, videos and everything else, it helps everybody, and it helps because we're all connected. We're all stakeholders in the electrical industry.
Dan, there's a very famous book called The 7 Habits of Highly Effective People, and one of those habits is synergize, and it's a proven method of pulling your resources, my resources, putting them into one pot, and the output of that is that we both equally benefit more than that we're currently benefiting.
Yeah.
It is basic shit that just.
But people are too selfish and ignorant to understand it,
Ryan. So can I just bring this back to arc fault detection, because I have quite a controversial thing to say. I don't fully understand it. I would like to understand it a lot more. Paul and I had this conversation and started writing on the TCW whiteboard, which I think I took a picture of, which I'll share with everybody. Arc fault detection technology software that these people are talking about. Dave, you mentioned it earlier on, that these devices aren't Internet of Things or Internet of Everything, and they're not connected to anything outside of a system. Therefore, they can't be continuously updated. So if you fit one into your installation, it is what it is on the day it's installed. However, I don't think it's clever technology. I don't think they've come up with innovative technology and software I think what they've done is there's 5 of us on this call, and we all have a different. What's the easiest way for me to explain this? How I would understand? There's 5 of us on the call, and we all have different accents, kind of. Paul and Dan have got the same accent. We've all got different accents, so we can understand where you come from in the country by your accent. And if we can understand the characteristics of the sine wave, and we can see, well, this is a sine wave looks like when there's an arc fault of a particular value. You haven't written software to identify that. You've came up with a piece of technology that monitors it, but it's not innovative software. I just think it's applied technology.
I think you're right in the respects of when we were looking at the Eaton one, the analysis of the sine wave and the arcs are very simple. Each part of the processor looks at different independent states and what's going on, and the software then stitches that together and analyzes at a incredibly fast pace. I don't think that's innovative, but when you look at the context of the ground fault circuit interrupters from America in the 70s, they didn't do that.
No,
they didn't have that technology in it. And that's why when people compare the American research they've done, which we did 2 years ago, and we used as a leading light for our quizzing and questioning, this new stuff that we've got in Europe, but it's fairly evident they have slowly introduced it around Europe using microprocessors. And we had some very honest feedback where they said to us at Eaton, when they introduced it in Austria and Germany, they had lots and lots of people rejecting them because they were getting nuisance trips. And it turned out that there was nothing wrong with the electrical installation. When the manufacturers went there and actually took the time, there was nothing wrong with the installation. It was actually the connected white goods. And that's a mega problem that I don't think any government wants to talk about, is the stuff that we buy and use on a day-to-day basis that's imported from around the world. These arc fault detection devices are now going to almost grade the quality of them and how they use the energy going into them, which is a whole different level.
Well, I think it's clever. I think that applied technology is clever, but I only think it's clever in the same way that, and you guys are looking at the picture, my watch that I wear every single day of the week has got this monitoring on that looks for arterial fibrillation, whatever you call it. And all it's doing is it's looking at the sine waves of my heart. It's looking at the rhythm of my heart, and it's detecting certain things. It's applied technology. It's good. It works, and that's why we've gone full circle around this, researching something that we had all the questions that are being thrown at us now. We've addressed them ourselves by communicating with each other and kind of looking at it, saying, yeah, we get it. Let's fight back to the manufacturers and get them to do things differently. We're now in a position where we understand it more than other people, so we probably have a duty of care to give people back what we've got. So
there is one thing that kind of I'll put my Welsh boyo hat on because he's obviously out with the family at the moment, but there's something called safety integrity level, and it's a risk reduction tool. There's a standard IEC 61508, and there are 4 SIL levels. And now on railways, for instance, if you're doing anything with signalling, you'll assign it a safety integrity level, and you will then assess risk and whether it's tolerated and how things will fail safe. And because of the nature of arc fault detection devices, we did ask whether they'd considered that these devices should have a SIL rating and the software should fail safe. In fairness, they actually said to us, look, we haven't considered it because we don't think we need it, because it fails safe anyway. And they were able to demonstrate the arc fault microprocessor being switched out of a device, and it's still working as an RCD with I think it was 6 flashes. So they had kind of designed the risk out just by default because they were really smart chaps. Whether every manufacturer does it, because I think it's fairly evident with AFDDs there are slight differences. I mean, John is the proprietor of all things AFDD for the group. I think you've got the largest collection now, John. What's your view on it?
Yeah, I've got several of them, and certainly this software thing, they are going to be different with the different manufacturers, just purely because it's from different places. So we're doing some tests on those to see how they actually react. I think there's a bare minimum of a standard, but obviously if it doesn't actually do the same thing for each one, then Can you actually hear what I'm saying on this one?
A little bit louder.
Yeah, yeah, so I've got quite a few of these things here. We're going to do some tests on those. And I think the problem is that if they are different things from different manufacturers and they're going to work in different ways, it's just going to add to that sort of level of confusion about people actually selecting these devices and installing them. And if we go back to that thing where at the moment they are recommended and not compulsory, the reality is that in the fairly near future, they're probably going to become compulsory, and it's not going to be something you can just choose to ignore. So I think it's important that people do actually get on board with these things as soon as possible, because, say, in some point in the future, in a future amendment or addition, they are going to be mandatory.
So I've got one final thought for me, which I would impart to installers. If these things have software on them, and the manufacturers know that there is issues with spurious tripping or poor connected loads causing unintentional tripping, that tells me there may be arcs that are yet to be discovered and yet to be programmed into these devices. So could it be that we are going to, over the next 5 to 10 years, have different generations of devices where they get better and better? And when do you then inform the installer, now is the time to go? I mean, let's be honest about the miniaturized Wilex one we've seen is, let's be honest, it's the foremost of the technology. It's about as advanced as you're going to get, low energy stuff. But in 10 years time, will it be different? Possibly. How are the manufacturers learning for different arc patterns? We don't know. Sorry, Dave.
Yeah, I think fundamentally the single module is going to be considered as the first generation of this device. You know, getting to a point of actually a credible device that we can use. Going on to what we mentioned earlier on, the issue is, as you're pushing onto, Paul, patterns of arc will change with different manufacturers as they evolve. And we had this gentleman approach us who's an E5 member at Coventry Elects who had this issue with a specific type of hand dryer, which wasn't being identified, and it kept tripping out a specific type of AFDD. And until these devices are connected into the internet where they could be pinged an update, I don't know as to how well, maybe Ryan would know, as to how well the longevity of the software would be reliable as a captured moment in time. But there would, I mean, they won't talk about that now because that would be considered as the next generation or maybe the third generation, which a lot of electricians would sit on their hands and wait for.
I think one of the things I've learned about software is it's massively frustrating. It's very frustrating kind of dealing with software. With the software that I've built or the team's built, we've built it from the ground up, and that's the same with this arc fault technology. So they've come up with technology or software to understand this. If for whatever reason they develop 1 million units and they sell 1 million units, and all of a sudden they learn something that is critical to that sine wave or whatever, they physically they can't go back and fix those 1,000 units. They would have to recall them. I think there was a recall on MCBs about 10 years ago. Something wrong with the internals of them. They would have to recall them and then re-chip them and then send them back out. And no manufacturer is going to do that, because software, the best way I've had it described from software perspective is the game as a kid you had where you build all the models up and then you put the marble in at the top and it goes down to the bottom. If you remember, it's all tubed. If you think of something more genius or to add into software, it's like taking one piece out of the middle of that and then building something into it to then to make sure the marble goes all the way to the bottom again. And that is a big problem, Dave. I think that would be a question that I think we should fire at the manufacturers, because it's worrying that.
One of the questions I had was, when I first heard about them, would there be a RJ45 port that you could plug a laptop in and update the firmware or the software, which we know they're not. They're completely sealed units. And I think with the software, the intelligence of the software, it's programmed to detect there's a void within that hexagon of what is deemed an unfriendly arc. So in fairness to the manufacturers, they've probably made it a closed system where they don't need to. However, I think with the lessons learned from around the Germanys and the Austrias, we're quite fortunate, as Dave says, the first generation of UK based stuff. We have got all the lessons learned from America, the development of the technology from the bolt-on modules that Siemens made in Europe through to the Eaton devices, which are triple gang. Now it's been miniaturized. I think the stuff we're getting is in a good place for Sparks to start going, right, okay, I have my basic MCB, I have my RCD. Now I've got a device that looks at the sine wave, and it looks for unhealthy patterns in the sine wave to protect against, dangerous releases of energy which cause a fire. I'm not going to use it everywhere, but slowly but surely I will start to use it in places. The hardest challenge for the electrical installer at the moment is very simple. If I select it, if I take the recommendation, I will lose the job. Some people, when we were doing our tours 2 years ago, some people were saying, if I go out and install AFDD at a school and it's constantly tripping out, then that school are going to then ring up another electrical contractor and say, mate, you boys put all these newfangled devices in and they're constantly tripping. And that electrical contractor will go, well, they're only recommended, swap them for an RCD. You go backwards.
But that's why it's so important for us to talk about this as, collective within the industry, to educate contractors and also, very importantly, clients, because,
I don't know why the industry bodies don't. I mean, wouldn't it be great for an NIC, ECA, JIB? Oh, hang on, they're all the same company, aren't they? Sorry. Wouldn't it be great for, say, like the NAPIT and ECA to do a industry online forum where they? Sorry, did I tell the truth there? To do an online forum where they debate the merits of why contractors. That would be really good. See some collaboration across the industry voluntary regulatory bodies. What do you think, Dave?
Don't see the ECA doing it anytime soon, do you?
Give peace a chance. Hopefully, maybe one day they'll all just get along.
When their boss retires, they might.
Yeah, I've done some consultancy work with some of my clients I've had for many years now, and obviously, I've had to kind of educate them on these devices. And these are, these are food manufacturers with 50 factories around the UK. And we'll talk about the technology, we'll talk about the cost, and thankfully now down to single module real estate of distribution boards isn't a problem, but a lot of the loads are beyond the threshold. And it came to the question of do we not approach this? And I said, well, the first question is, how many reportable incidents have you had where the source of the fire was due to a poor connection? And everyone in the room from different factories went, yeah, we've had a couple in the last 6 months or a year. I said, well, if you're going to have the other thing we haven't really covered yet is insurance. You're going to have an insurance company come in, just like it happened with SPDs. You have one scenario, and then the insurer will expect the overvoltage protection to be there, so this should not happen again. It's going to be the same trend with AFDDs, especially the manufacturers pushing. So it's really important for client education to get active now and for it to be done properly. And this is the slight frustration with just the big statement, this device stops fires. It needs to be a little bit more smarter than that, I think.
Yeah, I agree. I think probably one of the big pushes will be possibly insurers. Yeah, I can see insurers being propagators of that, to be honest with you. What's your view on it, John? I mean, you're still out there doing work in the field. Will you be using the device anytime soon?
The problem with domestic stuff, which is primarily what I actually do, is you're going to have this thing with the huge cost of them compared to not putting them in. I mean, currently you're looking at about £200 per device. So you put even a couple of those in a typical domestic, and you're literally doubling or tripling the cost of the consumer unit. So at the moment, if you went and quoted for someone and said, yeah, instead of it's going to be a £400 consumer unit, it's going to be costing £800, £1,000 instead. The reality is people are not going to go for that, even if you can say, well, it's going to have all these extra protections and it will stop your house burning down, because they're going to say the usual old thing, my house hasn't burned down for the last 50 years, so why should I bother now? And if you quote for that kind of thing and don't give them the option, they're going to go for someone who's just not going to put them in. So at the moment, because they are only recommended, I don't see really anybody, certainly the domestic market, even considering the things, purely due to the gigantic extra cost that's going to be involved.
I remember 10 years ago or so, when single module RCBOs had just become the fashion, and they were £100 easy at the
They
time.
were.
And they've come down, and that's going to happen. But I think John's right. We really need to kind of properly advise the commercial and industrial sectors. That's where a lot of this will go, and that's where hopefully the products will come down. But we need to remember they're only really single phase devices up to, what was it, 60 amp or so?
63 amp, yeah.
Right, so
And there is no free phase version of the device available. And it's also worth noting that in a industrial environment or heavy commercial environment, these devices won't work because they're only available as it stands with a pollution category of 2. So any hot or humid environments or heavy industrial environments, they won't work in. So realistically, at the moment, they are only really suitable for the domestic environment. When you go into big commercial installations, depending on the electromagnetic characteristics and whether you've got a switch room that's, you know, got condense and it's really hot, you need to be really carefully considering it. What I find weird, and it kind of annoys me, we're hung up on the word recommended. The whole damn book's a recommendation. It's a fucking guidance note. The regs is a guidance note. And yet we argue about the word shall. I mean, if you look at the regulations for arc fault in chapter 5, the wording is shall.
And again, I mean, it will become shall in the life of the 18th edition. That word will change.
Yeah, but the book itself is a guidance note.
Yeah.
And I can choose to depart from any goddamn part of that book I want, as long as I have the intelligence to be able to mitigate the risk and document the risk and show the journey I've taken in why I won't apply arc fault detection.
That's going to challenge the competence of many, I'm afraid, doing things like that.
Oh yeah, no, in fairness, I mean, I did a risk assessment exempting RCDs from railways where there's traction current because they don't work, which freaked a lot of people out. Not really, which is due to good old fashioned of overcurrent protection, placing outreach and all the other basic principles. But yeah, recommended.
Right. I mean, so before we finish today, is there any questions that have been asked that we haven't kind of put our opinions across for?
I guess the main questions are, there's the price, which is a difficult one. There is the testing methods. One of the interesting things that when Electrum came is the previous arc fault detection device. There was a big worry about having to put 250 volts through on your insulation resistance rather than 250 rather than your 500. And what they've done is they showed us on the devices now, once you switch it off, you can do the standard insulation resistance test without having to disconnect anything, which was good. So what other questions did we have?
Yeah, that's a good point, actually. Anything other than the single module device, the Eaton one that John's got, the twin pole one that is still available. If you do any testing or insulation resistance, you have to disconnect the supply and the outgoing load to protect the electronics, but they've evidently developed it to that point. I mean, my old house that I used to live in, that I went RCBO board in that, and they were like £59 a pop. So my board wasn't cheap. My board in my old house was about £600 to £700. I chose that because I wanted that protection without that nuisance tripping. A lot of the industry has settled into a huge comfort zone of split board. And I think a lot of the domestic installer industry says, that's it, I'm not moving from that. I know loads of domestic electricians who've said, bollocks, that's all I'm doing, split RCDs.
Well, that's the 17th edition generation, isn't it?
It is.
That's it.
It's weird. Yeah, that's actually freaks me out when you say that, because I was a 16th edition generation and now we're into 18th edition. So you can genuinely see those changes over time and how that immediate brick wall that people hit up against. I just don't think the industry bodies have done enough. Going around and saying recommended only is stupid, given the whole book's a guidance note. I just find that really dumb to even suggest that. I find it actually condescending to the memberships, to be honest with you, to say that, because you're treating them like idiots. But just a view.
The other interesting things that was brought up was the heat buildup in these devices and whether or not that would be a significant issue. It was interesting because I didn't know the answer, and when a guy kind of sent it through to me, he said, surely if you're compacting everything in there, there would be an issue of heat buildup. And so I asked the manufacturer, and they came back and said, as new devices are developed, I don't know what the standard is. It would be nice to see that standard.
Assembly standard.
Yeah, as devices are developed. So when RCBOs were developed, a consumer unit would have been tested for heat with RCBOs. That standard will now be applied to arc fault detection in every single unit on that fuse board, and it would still need to meet the same heat resistivity or whatever it is in there if it was RCBOs, MCBs, RCDs, and arc fault detection. So
I should imagine there'll be. I mean, each manufacturer probably provides some specific information for that as well. I know with MCBs and RCBOs, I did a video on this on my channel recently where I can't remember which manufacturer it was I stumbled across, but it said basically 32 amp breakers, if they were loaded up to 80% of their demand. Yeah, bear in mind, most ring finals are never loaded near that, are they? But if we had them loaded on that demand and they were adjacent to each other, it derated them to like 25 amp each or something like that. So if they were loaded significantly, then there would be some level of deration. But the manufacturer's instructions again should hopefully clarify all of that.
I think it was the Hager one, if I remember rightly, Dave.
Maybe.
But I think that in simplicity terms, I took that as when you group a big bunch of cables, say you've got a bit of 4x4 trunking, you've got a load of twin and earth in it, you bunch them all together, you bring them into the board and they're all bunched in, that heat can't dissipate, you're going to derate the cables. But the UK assembly standard is BSEN 61439-3 as it stands at the moment. And that standard, again, what they will do is when you put all of the same breakers in, they will then expose that to corrosion, heat, humidity. They will run fault currents through it. They will ensure that they can absorb 6 or 10 kA. They will ensure that at maximum demand of all the breakers, that there isn't a thermal interference between the performance of one breaker or the other. It's quite a fascinating subject, to be honest, because I've done a lot of it on rail. When we've literally tried to blow up and set fire to various consumer units and stuff, and we found, I mean, if you go on London Underground, everything was the Crabtree C50s and the next generation, because it was a really robust board working in 90+ degree humidity, so those boards worked. So a lot of work has gone into that. But yeah, now that was an interesting question actually, because these devices, John flagged it in his video, the hidden cost of ownership. Running the microprocessors, the power electronics in these costs money. So if you're putting them into social housing, how much is it costing to run these a week? I think, John, based on your calcs or on the video you did, I think we worked out that if we had a 10-way Eaton board, it would cost like £2,000 over 20 years just to run the board, to run the processors in it.
Yeah, it was something like it was so many watts per device, and if you had so many, and it adds up over the course of a year, and obviously the lifetime of the whole installation. So it's certainly a thing to consider. And again, that's not particularly new, because even RCDs, even just sitting there, they're still going to use that little bit of power to run the electronics inside. So definitely something else worth considering. But
we don't as an industry, do we? And nobody in the industry tells people about that, the hidden cost of ownership. And this annoys me as an asset manager, client now hat on. You want to know the hidden cost of ownership. You want to know the total cost of ownership.
That stuff may have started creeping in Part 8 if we actually adopted it, or when we finally will adopt it. You know, we flushed it. We flushed it out, but it's not going anywhere. It's not going anywhere. It's going to come in.
That is actually a good point. If they're really going to go in energy efficiency, then they should be looking at that. Are we going to look at equipment that has the standby running times? Is there going to be devices that switches off automatically equipment that's running on standby? How do you switch off a consumer unit if it's constantly using energy to monitor and manage? So yeah,
I can categorically state whether this is a first. The next amendment was a balls up by the IET. The amendment after that will have the Part 8 in it. Energy efficiency will be in there.
Well, it's in that annex that nobody actually reads at the moment anyway.
Yeah.
There's an energy efficiency annex, which is like the tease for when everybody gets the ump, and then they can go, well, we did tell you. The interesting thing for me is when we're now wiring 2.5mm lighting circuits and 4mm radials for socket outlets, because that will give the socket outlet manufacturers an opportunity to sell a new 18th or 19th edition compliant socket. Great marketing.
Yeah.
Thank you very much.
Just a separate one, showing the guys the Crabtree one, which the thing that I liked about this is my bugbear putting my client hat on when I worked in social housing was the cost for me when we were talking about double pole and we were saying, right, we have to have a double decker consumer unit. The cost to fit these was it was just going to be a no-go. So a bit of an interesting statistic for you. Within social housing now, right across the country, pop quiz, when did RCD become something, or when did RCD appear in the regulations as, I'll give you a hint, for sockets for outside use? What year was that? They've always been in there in the 80s and stuff, but when did it become? I'll just give you a little bit more of a hint.
I think it was 16th edition amendment 3, wasn't it, that introduced?
Was it the yellow book?
Yeah, it was the yellow one, wasn't it? The yellow one was really controversial. The yellow 16th edition.
In 1993, the 16th edition came out.
Yeah,
and it referenced sockets for outside use. That's 26, 7 years ago. 40. Paul is now showing us a copy of it. Social housing is right across the country. Still have upwards of 14% of the properties in the UK don't have any RCD protection whatsoever. So
really,
yeah. So one of my biggest concerns were, we bring a device like this in, and we see it's fantastic, it's amazing, and RCDs, they reckon if you fit an RCD in there, you have a 98% chance of survival if you come into contact with an electrical installation, and that number is significantly increased if you press the button every month. That was from our friends at Beamer. They published a big document that said that. But yet we're still in a position 27 years later, or whatever the calculation is, where they still don't have the money to fit RCDs. So my concern was, you're never going to fit these. These aren't going to go in now for another 20, 25, 30 years. However, as you can see, as we can see, but you can't on a podcast, the new Starbreaker arc fault detection, if you've had a Starbreaker board since 1992, these will retrofit into that board. Now that is considering the client rather than just going out there to money grab. And that really tickled me. I really liked the fact that they'd considered the impact on clients' pockets with this specific device.
Yeah, you did get a bit excited about that, Ryan. In all fairness, your social housing excitement button did get pushed quite a bit. But I do remember actually when RCDs, that wonderful clause, I'm pretty sure it was in the yellow book, when the wonderful clause said it was for sockets supplying outside equipment. So I remember doing private jobs where I would change a board, say rip out a Wilex board, put in a split load board. And I remember the split load board literally had like 2 circuits on it. And for me, I was quite happy to fit boards with MCBs in it. But then this new RCD thing came out and it was like, well, they're on the 3rd floor. Why do I need RCD protection anyway if you're on the 3rd floor? Yeah. And I think what we've got is generations of regs books out there.
I remember in the life of that yellow book, I was a void supervisor, and we'd have, for every periodic inspection, as we called it, we'd have to install a RCD adjacent to the existing 3036 board just for the socket outlets, as you say, Paul, if it could go outside. So I'm thinking about that period of time as well. The 17th obviously brought in that nonsense about cables buried in the walls. We had that new split load RCD rubbish.
Engraved sockets. Here's an interesting one, a funny story, because everybody likes funny stories. RCD protection, you just said on the 3rd floor. Why do we need arc fault detection on a 3rd floor? Because it's not for outside use. When I worked for a local authority, I went to a property of a man who was charging his scooter on the hallway, on the landing outside his property, still in the property, still within the high-rise building, but he was charging it outside the lift, outside, and he was putting the plug through the letterbox and charging it on there. We said, you're not allowed to do that. And he says, where would you like me to charge it? And we says, either inside your dwelling, or you need to find somewhere outside to do it. This property didn't have any RCD protection. He then took a number of 6-meter extension leads from the 7th floor, plugged it into his kitchen, took it out over the balcony, and multiple extension leads down to the ground floor where he created his own. He put a lock on the side of the building, a big metal pole on the side of the building, and padlocked his scooter to the side of a building and charged his scooter outside from the 7th floor using about 20 of these 6 feet. So yeah, these are the things we have to deal with.
It gives a new meaning to vault drop, doesn't it? Really, to use a slight pun there, but
yeah, it was interesting. Yeah, it was interesting.
yeah, that's insane. That's madness. It's also worth talking about with AFDDs very quickly. Testing and inspection. There is a device in America which tests the arc fault devices. I think I actually put a link to it on the response thread on LinkedIn. There is a device available. I'm sure there will be devices that come out and do some very basic series arc simulations. I think it's just a matter of time. They do self-test anyway. It's built into the software, and they've got lots of fail-safe approaches to them. So for the first time ever, I can't believe I'm saying this, but I'm actually not too fussed about it. However, every electrician under the sun likes to be able to show Mrs. Jones, this is what I've done and this is how safe it makes your home, because RCDs protect external if you're going outside your installation, and leakage. Now arc fault protects against the stuff that John Ward regularly sets fire to, blows up and pulls apart. In fact, there's an argument straight away. Why do I want arc fault detection? Go and watch some of John Ward's videos. Look at some of the crap that he gets sent. I still can't believe that my bug repellent, John, is just a blinking LED.
Yeah, that's a not an unsafe device, but just a device which doesn't actually do anything and basically is just sitting there wasting away power. So
my missus will be devastated. Looking forward to that video, John. Okie doke. I think have we?
Yeah,
Dan?
I mean, Dan, any questions now that you've been educated with
Yeah,
this?
Dan, are you Mr. AFDD now?
Well, it's been quite interesting listening to all you talk about it. And yeah, I think this is only the beginning, isn't it, really?
It is.
Like, literally just the beginning. And I think a couple of things that have been said, that it's really important to keep up with the times, because the electrical industry moves so bloody quick, like literally so quick with technology and the way we use electricity. And so, yeah, it would be good to get, if any manufacturers are listening to this podcast, or any bodies, whoever,
sleep.
it would be it'd be interesting to see what they have to say about what's been said, because we're open to discussion.
I'm sure they'll tell us, because once we're finished, we'll hopefully get this out and online. It's worth saying though, you're absolutely right. It's really weird. I work in mechanical and electrical industry, yeah, and new technology is a nightmare for me because I'm very stuck in my ways. I'm a 16th edition lad, so now I'm on 18th edition, and I have to keep up with the technology. I mean, I was at the IET last week, and when I was there, I watched a young person get up and talk about how when we fly to Mars, that we will create 12 tons of poo, which they have invented something that will convert that poo to 3D printing material. I mean, hello, there's some serious technological advances out there. I know it's got nothing to do with electrics, but these generations coming through, they're getting smarter and smarter and smarter. And the last thing I want to do is get to the age of 55 and have someone going, yeah, you're a dinosaur, mate. You've not kept up. And for me, knowledge has always been money. It always converts to money in our industry. The more you know, the more you're worth.
Yeah.
The more people should pay for your worth, as Dan.
So Meenan, I've got a bit of a confession.
Go on in.
We are just on that little bit, because that was really interesting about the poo and 3D printing.
It's on Facebook. You can watch the whole thing.
Yeah. So E5 Live on Instagram's just heard that, which was fantastic. So just give everybody a wave.
Hello.
Yeah. So this is how E5 record podcasts. And you'll hear this on the podcast. So
yeah, this is how we rock on at 10:30 on a Sunday night.
A poo into 3D. Anyway.
Sunday evenings.
Right.
Should we wrap this up, guys?
Yeah, wrap this up. Yeah,
because we're changing the mood. We're talking about poo and Mars. So
sorry, Ryan's just made that very obscure. Final thoughts.
Final thoughts from me are that the manufacturers have been great in being transparent for E5 to come along a journey with them to understand the technology. The technology is in its infancy. The technology is required to protect because it's a new level of protection. As Ryan's mentioned, it's going to take a long time for it to be fully introduced and fully implemented. All we need to do is keep being educated by the manufacturers regularly about how they work and how they're bettering the industry, so we can help electricians to understand and have some faith in the devices. So I think my main input is manufacturers need to be a little bit more. You mentioned earlier on about electricians being a bit stupid. We need to think more sensibly about what information we give to electricians so we can give them to the client. If we give them to the client, clients might then invest in them, especially if they're only really suited for domestic. Yeah.
John?
Yeah, I'll just say that although these things are fairly new and obviously a lot of people apparently don't like them, the reality is they are around, they're not going away, and at some point they're going to become a required item. So make the efforts, actually find out about these devices, what they're for, where they're going to be used, because at some point you are going to need to be installing these devices, so ignore them at your peril.
Mm-hmm. Mr. Dempsey?
Yeah, no, it's really good to have this conversation, and it's nice that people are challenging it, and we welcome that. And we are at Sandown a Thursday, Friday. We're there to kind of answer anybody's questions, because we have spent some time understanding these devices. We will continue to work with the manufacturers, and we don't just meet with the manufacturers to try and upskill ourselves. We've managed to get Electrium or have kindly offered something. Hasn't materialized yet, but they have kindly offered to help out some training establishments from our meetings. So we don't just meet people to kind of give them to hit them with a stick. We do talk about the industry, we talk about training. So it's if anybody's got any questions, fire them away, send them over to us, and we'll do our best to answer.
It's worth adding as well onto that, for my final thought, is that if anybody's wondering, again, we don't get paid for this, but we do ask manufacturers to support colleges, learners, further education with whatever they can, because that needs to happen, because we see it. Dave knows it, the pain, more than most of us as to the state of the training sector, so anything that can go back into that is a joy. Also, I think for my final thought is we are now in the time of RCDs. When RCDs came out, it was, oh, no, complete rebellion. The difference between then and now was there wasn't an E5 when RCDs came out to appease the sparks and say, look, we've gone and done the work independent of any commercial operating model. So calm down, don't get your knickers in a twist, and let's just work the problem and educate accordingly.
And on that note, thank you everybody for listening to this podcast. As ever, it's going to be on all major platforms. We're going to post it on social media, and we ask you if you can share it, comment, get involved. This is an open discussion. See you on the next one.
Peace.
Bye.